Important questions other than these exercise sums. Let's take page number 28, sum number 46, example 46. This is a very important board exam sum wherein set A, which is 1, 2, 3 is related to itself, which means 1, 2, 3 is related to 1, 2, 3 only. Okay, how many one-to-one functions are possible? How many one-to-one functions are possible? Okay, 1 to 1 means 1 has to be mapped to 1 only. I'll tell you what, if there are n in this, n elements in this and n elements in this, the formula for 1 to 1 functions will be n factorial. How they got it is like, this 3, this
1, 2, 3,
this 3 can be mapped in 3 ways, yeah, separately in different functions. This 2 can be mapped in 2 ways because this 3 would have been already mapped to 1. So 2 can be mapped to 2 ways and this 1 can be mapped to, so that's how it's 3 into 2 into 1. So you have to take the what is in the right side and start mapping it. So therefore the formula you have to check this is n factorial. Correct? No, you have to take this element, this can be done in n ways. The next element in here can be done with, if this can be done in n ways, the next element can be done in n minus 1 ways, then n minus 2 ways, n minus 3 ways, therefore it becomes n factorial ways.
But n is the number of elements on the...
No, wait a minute. Now to give you clarity, this was n elements, so you still have some confusion. What happens if there are n elements here and m elements here and stuff like that, okay? So if you have m elements here, take this mth element. It can be mapped in n different ways, correct? N different ways. The next element here will be mapped to n minus 1. So it is this first one's factorial and not the second one's factorial. If this was m numbers and this had n numbers, the nth element would be mapped to m different ways. This would be mapped to m minus 1. So then therefore in that case it's m factorial ways. Are you clear? Yeah? And so then that's about it. Okay, so this is about example 46. I've given clarity. Yeah, so next let's go to example 47. Okay, so in a set, not exactly example 47. Okay, we can do example 47. How many equivalence relations are possible? Generally, let's not answer this 47th question. Generally, let's write how many equivalence relations are possible. You know, it's 2 to the power n minus n, which is 2 to the power 3 minus 3, which is 8 minus 3. There are 5 equivalence relations. This is the general formula. But they ask you to list the number of relations, R1. The first equivalence relation must compulsorily consist of 1, 1, 2, 2 and 3, 3. You must be thinking this is only reflexive. No, this is reflexive, symmetric as well as transitive. That's the first thing that you should know. For mainly for a reflexive alone, each and every element in set A should be reflexive. Otherwise, if it's only 1, 1 and 2, 2, then it is not reflexive. Every element in the set A should be reflexive. Then only you can call it reflexive. And this itself is reflexive, symmetric and transitive. Even though you know 1, 2 is 2, 1 only is symmetric, you don't have to worry. It's 1, 1 which is ultad also, it's 1, 1. And when you don't have anything to compare, transitive is like 1, 2 and it's 2, 3, then there has to be 1, 3. But when you don't have anything to compare also, it is simply transitive. So something that you need to know. Then relationship 2. Let's write a 1, 1, a 2, 2 and a 3, 3 compulsorily, and let's include a 1, 2 in this. If you include a 1, 2, you necessarily have to write a 2, 1. Correct?
Yes.
And yeah, so this is another reflexive relationship. Let's do it. Another one, R3 is 1, 1, 2, 2, 3, 3. Compulsorily must be there. Then I can include a 1, 3 and so a 3, 1 and close. Relationship 4 will be a 1, 1, 2, 2, 3, 3 and you will have a 2, 3 and a 3, 2, correct? So the relationship is 4 is over. I am going to write relationship 5 wherein I am going to use 2 of them. I use 1, 2, 1, 3 and 2, 3 individually, each and every element individually. Now I am going to use 2 of them, 1, 1, 2, 2, 3, 3. Then I am going to use 1, 2 as well as 1, 3. So it will become 2, 1 as well as 3, 1. But when I do that, I will be forced to write 2, 3 because I'll be forced to write 2, 3 because a 2, 1 and a 1, 3, if it has to be equivalent, it has to be transitive, it has to have a 2, 3 and a 3, 2 and therefore there are only 5 equivalence relations. So this is a question which is not part of the question that I am going to do now. 47th question, it says set A is 1, 2, 3. It has got, oh, that's this question.
That's all.
This condition, if this R5 alone
When all
is the answer for 47, because if you are going to include a 1, 2 and a 2, 3, you will necessarily include 1, 3. Therefore, there is only one equivalence relationship possible, right?
Yes.
No.
Should be.
Containing 1, 2 and 2, 3, then show that the number of relations containing 1, 2 and 2, 3,
But
they are saying it's 3. If you are going to write 1, 2,
but it says it shouldn't be symmetric.
huh?
47th law, it says it shouldn't be
Oh,
symmetric.
it is not symmetric. Okay. So this is for an equivalence relation. So 47th question is not symmetric. So let's write it. 1, 1, 2, 2, 3, 3 for it to be reflexive. So it has to necessarily contain 1, 2 and it has to contain 2, 3, and wherein
It should
show
be
that the number of
transitive.
relations containing 1, 2 which are reflexive, transitive, but not symmetric. So if it's not symmetric but it can be transitive, let's,
So 1, 3, you need 3, something.
I can't write a 2, 1, it will become symmetric. I can't write a 3, 2, I can't write a 2, 1 because it will become symmetric. But it has got to be transitive. So 1, 2 and 2, 3 means it will become.
No, you need 3, 1, no. See, because you will get 1, 1 over here then.
What is it?
You need 3, 1. 1, 3.
No, the question says 1, 2 and 2, 3 are compulsorily there. So I have just written what is in the question. 1, 2 and 2, 3 are compulsorily there. If it should not be symmetric, then I should not write a 2, 1, I should not write a 3, 2. Okay, but it has got to be transitive. Look at this. A 1, 2 is there and a 2, 3 is there. It should necessarily consist of 1, 3. And to make it symmetric, it has to have a, it should not be symmetric. It should not have a 3, it should not have a 3, 1. So what else is 1, 2, 2, 3, 1, 3. Now total number of desired relationship will become symmetric, and also which is not this, the total number of relationships is 3. They are saying total number of relationships 3. Let me pause. So let's write the relationship 2. Relationship 2 will be let's write a 1, 1, a 2, 2, a 3, 3. A 1, 2 and a 2, 3 must be compulsorily there. Now let's write only this 2, 1. Let's not write 3, 2. But to make it transitive, I should write 1, 3 and close it. So the fact that the 2, 3 is there and it's not 3, 2 shows that it's not symmetric. Each and every ordered pair should be symmetric. So that saves us from trouble. So it's not symmetric. Don't say that 1, 2 is there, 2, 1 is there, it's symmetric. That is there, but 2, 3 does not have a 3, 2. A 1, 3 does not have a 3, 1. So it's not symmetric. So let's go to next one. Relationship 3. Wherein you have a 1, 1, 2, 2 and a 3, 3. A 1, 2 is compulsory, a 2, 3 is compulsory. Let's write now a 3, 2 and a 1, 3. Let's not write a 2, 1. So 1, 2 is not symmetric, therefore it justifies. So like that when we write. Now you try to write a relationship 4. Yeah, let's try. Okay, 1, 1, 2, 2, 3, 3. You write a 1, 2 and a 2, 3. Okay, now
You can't do it.
You have to compulsory have a 1, 3 which is already here. So there is only 3 relationship of equivalence possible when you write like this. So that answers the example 47. But when such a conditions, when they ask you Mahima, number of relations, you can't put the formula 2 to the power n minus n for this question because there is a condition has been given. When the condition is specified, when the condition has been specified, it has to be an equivalence relation, a complete exhaustive equivalence relation. So unless it is, so you can't use the formula 2 to the power n minus 1. So but when they give you only certain things exist, then there is a problem. Okay, you can't use that formula. Are you clear? So 3 relationships are possible. Let's write the next question, 48th example. Okay, we struggled a bit doing 47th, right? A little bit, even though we are clear.
Because we didn't know that 3.
Each and every element should be symmetric. In the ordered pair, every element should be symmetric. Are you clear? So let's go to 48th question. In a set A, which is 1, 2, 3, it should contain 1, 2 and 2, 1. So let's write relationship 1. Are you coming? 1 1 2 2. If you're not interested, then I'll call somebody else. Then show some interest. 1 1 2 2 and 3 3. 1 1 2 2 and 3 3 is one equivalence relation. But it should come. They said show that it should compulsorily contain 1 comma 2 and 2 comma 1. The fact that 1 comma 2 is 2.
Number of equivalence. Yeah.
1 comma 2 and 2 comma 1 are compulsory there, okay? Which means 1 1 is there, so it becomes, this is already an equivalence relation, symmetric also, okay? Then I'm going to,
Transitive? Yeah.
it's transitive also, so it's equivalence, okay? Now I'm going to write another one, which means I'm going to bring in something else. A 1 1, a 2 2, a 3 3, a 1 comma 2 and 2 comma 1 are compulsorily there. So I'm going to bring in another factor. What can I do? Can I do 2 comma 3? So I have to necessarily write a 3 comma 2. In the process of which I told you I will be forced to write even 1 comma 3. We just saw that. When you include 2, you have to include the third one. So 1 comma 3 and 3 comma 1 will also come. Hence there will be only 2 equivalence relation when you have 1 to 1 to 1. Are you guys clear? So let's go to next question.
51?
Next question is not there. Okay, so I finished 46th example, 47th and 48th. 49th is omitted, okay. 49, 50, 51 and all is omitted. So let's come to this question. Like see, you know, the miscellaneous first sum is about Goff and Fogg. It's about invertible function. When they say Goff is equal to first sum in the miscellaneous, when they say Goff is equal to Fogg is equal to I, this word is there, it means it's invertible function. So the question is about whether it's invertible. You do normally how you do invertible, na? F of x1 is equal to, it's a linear function. It will be 1 to 1 and on to, hence it will be invertible, and you know how to find an inverse, very simple. So let's go to second question. Second question is also about invertible function.
W defined?
Whole number to whole number. When it is whole number to whole number, it starts from 0. And you know that, so look at this, Mahima, if it's a second question in miscellaneous is whole number to whole number, it starts with 0, 1, 2, 3. And when you put it in the formula, 0 is related to minus 1, but we don't even have a minus 1 in the range. No, it's given here. It's given that if n is odd, it is n minus 1. And if n is even, it is n plus 1. So 0 will be related to 1. 1 will be related to?
How 0 will be related to minus 1? I don't know.
0 is an even number, so even number, it's n plus 1.
Oh, even.
And 1 is an odd number. So formula is 1 minus 1 is 0. So it seems like it's 1 to 1 as well as on to. It's linear functions, right? And you know how to write it, correct?
Yes.
So let's go to next question is f of x. I just taught you how to find f of, I don't have to show it, right? f of x, where f of which is x square minus 3x plus 2, wherein in the question wherever x square is, you will write this only, x square minus 3x plus 2 the whole square minus 3 into x square minus 3x plus 2 plus 2, and you will write the answer for this. Solve it and write the answer for this. So let's go to fourth question in miscellaneous. F of x is equal to x by 1 plus mod x. Yeah, and you know when x is less than 0, the function f of x is going to become x by 1 minus x. When x is greater than or equal to 0, it will be x by 1 plus x. And so you have two different functions, correct? So you can prove this, take this left side functions. Look, take this function and find it is 1 to 1. This is also
1 to 1.
Will it be 1 to 1? If you take it separately, yes. If you take it separately, it will be 1 to 1. If you take it combined, I am not sure. Okay, but even then there is a negative value up.
What is separately combined?
If this minus 2 is going to become plus 2. In this minus 2 is going to become plus 2. But yet that drop will be minus 2. So it doesn't affect our answer. It will be definitely 1 to 1 and on to. So take this separately. Call this as f of h of x. Call this as g of x. And combine it and prove that this is invertible and this is also invertible. Correct? And so that completes it. Logically also you know it's invertible, right?
Yeah.
So next question is the fifth one, where is f of x is equal to x cube. I told you it's an ogive. A ogive will be 1 to 1 and on to, provided it's real number to real number. Not when it is natural number to natural number. Natural number to natural number, it will be 1 to 1, but it will not be on to. I have taught you this. I am recalling that.
Yes.
So it's real number to real number, it will be definitely 1 to 1 as well as on to. That's done. But the question is only about injective, 1 to 1 only. But if it is for bijective also.
When we taught us this horizontal testing, which is very easy. Like if you imagine a horizontal test, it will automatically be 1 to 1.
I don't know all that, but
Horizontal line
this
then.
is like graph, right? You know, every value of x has
Just
got a
imagine
value
a
of
straight
y.
line passing through it from the horizontally. If it intersects at one point, then it will be an one to
No
one.
need to confuse all this. Just
Very easy.
what is that you're saying?
See, imagine one straight horizontal, like x-axis, no?
Straight line, horizontal
It's
line.
passing like this, like what
Okay,
X-ray machine
straight line. Just it's going down, down,
So
down.
it's every point is cutting only once, no? So it's one to one.
So then, therefore, it's 1 to 1.
Yeah.
Okay. But you can think just by the graph also, you know, it's 1 to 1. You don't have to think like that. Every value of x has got a unique.
Draw like different types
Come
of graphs,
on,
no?
Mahima. Why should you do all this? Every point of x has a unique value of y. What will you do if it's a natural number to natural number? You will still do this and say it's on to. Don't do all that. You have to think logically. What I am doing only is correct. Okay, so then.
We don't take that as
No. Okay, so then next is about
x cube.
sixth summanon was omitted. Okay, completely omitted. Any linear function, seventh one, obviously it will be 1 to 1 and on to linear functions, correct? X is equal to 1, it's 1. Okay, forget about it. The next question that I discussed with others is just go to the last 16th question. The 16th question in miscellaneous is what I discussed with everyone. There's a 1, 2, 3.
Maybe everything is deleted.
The number of, rest of it is deleted. The binary operations and all is not even there. The number of relations containing 1, 2 and 1, 3. So imagine, no, you can't write 2 to the power n minus n formula because the condition has been given. Number of equivalence relation? Yeah, obviously they must be referring to equivalence relation. No.
So there are number
Which
of
are
relations.
reflexive symmetric but not transitive. So reflexive means
1,
you must
1,
compulsorily have 1,
2,
1, 2,
3,
2 and 3, 3.
1, 2, 2, 1.
Okay, which has to be symmetric. So you can include 1, 2 and 2, 1.
2, 3, 3,
1, 2 and but not transitive. You can't have a 1, 1. So you can't write this. Slow down, Mahima. You are always constantly in a hurry to say some answer. You are not listening. You are always wanting to run faster and you say something which is mostly wrong only. Slow down and think. It's 1, 2. You can't write a 2, 1 because if you write a 2, 1, it will become transitive.
Yeah.
If you write a 2, 1, there will be 1, 1 which will make it transitive. It cannot be transitive. So never write a 2, 1. You can only write a but it's got to be symmetric, right? So never don't write 1, 2.
That's all till here only.
Containing 1, 2 and 1, 3 has been given. So you have to write a 1, 2 and a 1, 3 compulsorily. Yeah? You have to write. But it has got to be symmetric but not transitive. So you if you write a 2, 1, it will become transitive.
Yeah, transitive.
It will become transitive because you have a 1, 1. So you can't write a 2, 1.
Then what will you do?
Okay, let it be. Let this be there. Okay, let this be there. Let's play around with this. 1, 3 is there. Let's write a 3, 1. 1, 1 is there. It has to be symmetric but not transitive. So a 1
What if it's only
containing 1, 2 and 1, 3 means I should necessarily write these two as like this and include something else. Include a 2, 3 and write a 3, 2. I still have a 2, 2. I can't have it as transitive but not transitive. A 1, 1, 2, 2, 3, 3 and it should compulsorily consist of 1, 2 and 1, 3 which are reflexive and symmetric. Since it's got to be symmetric, I have to write a 2, 1 and 3, 1 which is inevitable. Correct?
It's 2, 1 and 1, 3 up to
3, 1, 2, 1 and 3, 1 which is inevitable. Correct? But it should not be transitive. Let's see if it's still coming transitive. 2, 2 is there. 2, 1. 3, 3, 3, 1. 3, 1 is also there. 1, 3 is there. 1, 2. 1, 2. Okay, 1, 2. I have to include a 2, 3. If I include a 2, 3 in this, 1, 2 and 2, 3 is there, 1, 3 is there. It's becoming transitive. And if I write a, but it should not be transitive. I have to write a 3, 2. I should not have something here. What is it? 3, 1 is not there. It's there. I'm lost in this sum. So yeah, I just could find out. See, can you see? We don't have a 3 comma 2. Yeah, we have a 3 comma 1 and a 1 comma 2, which means the 3 comma 2 has got to be there. I'm not writing that, which means it is reflexive, symmetric, but not transitive. Correct? So that completes it. Even this Mahima is saying a 2 comma 1 is there, a 1 comma 3 is there. You don't have a 2 comma 3. So then therefore it's definitely not transitive. But what happens? Okay, what's the answer for this? Can you just see? 16th one, is it 2?
Yeah.
I think the answer must be 2. Let's see.
One.
Only one, na? Only one. Okay, so then that's all. You just have to leave it like this. You just have to leave it like this. There's only one. So this is not transitive. What I was trying to think is, see, look at this, Mahima. I have a 2 comma. You said 2 comma 1 and 1 comma 3 is there. I'm just thinking, why can't I make only one thing as transitive? When I make one thing as transitive 2 comma 3, then this has got to be symmetric. I have to include a 3 comma 2, which will make the other thing also transitive. That is why we have to stop with just one. Okay, so that I hope it's clear. Please rewind and see what I have said. So there's only one which is possible. Let's go to 17th question. A set A has got 1 comma 2 comma 3. Number of equivalence relations compulsorily consist of 1 comma 2. So relationship 1, which has got 1 comma 1, a 2 comma 2 and a 3 comma 3, which consists of only
1 comma 2.
1 comma 2. It's got to be equal. It has got to be equivalence. So I have to write a 2 comma 1 and it's also 1 comma 1. So it's sorted. So we got one equivalence relation, correct? Which is reflexive, symmetric and transitive. I can now include another one. Let's write another one. R2, which is 1 1, 2 2, 3 3. 1 comma 2 has to be necessarily there, so I have to write a 2 comma 1. I can slowly include a 1 comma 3. And so then therefore I have to write a 3 comma 1. In the process I told you we have to necessarily include when you include 2's, you have to include the third one to have an equivalence relation. So therefore you have to write 2 comma 3 and 3 comma 2. Therefore 2 is the answer for this. Can you just check?
Yeah, correct. I checked.
Checked. Okay, so let's go to 18th question. So let's go to 18th question.
9 is related, no?
When you look at the 18th question, as soon as you see, it is nothing but mod function or signum function. Signum function. Because it's either plus 1 or minus 1. So therefore you should identify that the f of x is equal to mod x by x. Correct?
But it is greatest integer function.
No, that is f.
Yeah.
That is about
Signum
f.
function.
The function f is the signum function. The function g is a greatest integer function. Yeah, you know that they both are definitely not 1 to 1 and on to. The fog will also be not 1 to 1 and on to. Goff will also be not 1 to 1. I don't know. They don't have to worry about this question. I don't think Goff and fog is there. So 19th question.
That's
The number of
binary
binary. That's all. So I'm done with these questions. So please become very clear with this. Next is equivalence class. We discussed something from a Balavidya Mandir question paper. So I will send you a BVM question paper. The link of it. Please go through that. And there was a question there where it was A comma B and C comma D. The relationship is valid is A plus D is equal to A plus D comma B plus C. This is the condition that they have
They
given.
have write R in the middle.
For it to find that it's reflexive, you have to write A comma B with an A comma B only, and A plus B is equal to B plus A. Therefore, it is reflexive. Then you have to do A comma B is related to C comma D. Is C comma D related to A comma B? You just do this.
You get
C plus B is equal to D plus A. Yeah,
yes.
it's the same as this, right?
Yeah.
No,
Yeah.
I wrote CD here and AB here.
No, it will be
C plus B, yeah, C plus B is equal to A plus D, it's still the same. Can you see? So this is also true, therefore it's symmetric. For reflexive, it's B is related to C comma D. C comma D is related to E comma F. So you should know that this is given. A plus D is equal to B plus C. Similarly, C plus F is equal to D plus E. From this you have to prove that extremes are related. A comma B is related to E comma F, which means you have to prove that A plus F is equal to B plus E. This is to prove. Yeah, take these two equations and solve. So A plus D is equal to B plus C, and how do and C plus F is equal to D plus E. Yeah, can you see? You want an A plus F, correct? A plus F you want, and you want a B plus C. Yeah, so let's find what is A from here. First equation. What is A? B plus C minus D. What is F from second equation? D plus E minus C. So you want an A plus F, correct? Which is B plus D plus what? D and D get cancelled. C and D get cancelled. You have a B plus E, and which is what you need to prove. Proved. Very, very important question.